Hello children, we are discussing the chapter electricity. In that chapter we have discussed certain topics, that is what is electric potential, what are electric charges, what is their properties, unit of electric charge, that is coulomb, what is 1 volt, what is electric current, what is 1 ampere. We have discussed all those topics. In the previous video we have discussed Ohm's law. First we'll revise that topic. Ohm's law was proposed by George Simon Ohm, and according to this law, at constant temperature, the potential difference applied across the ends of a conductor is directly proportional to the amount of current flowing through the conductor. एक कंडक्टर के एंड्स के अराउंड जो पोटेंशियल डिफरेंस कनेक्टेड है वो डायरेक्टली प्रोपोर्शनल होगा अमाउंट ऑफ करंट फ्लोइंग थ्रू दैट कंडक्टर. That is, V is directly proportional to I. When we remove the sign of proportional, we get equals to, and with that equals to a constant. In that case, the constant of proportionality is R, and R stands for resistance of the conductor. What is resistance? The hurdle or obstruction in the flow of electric current is known as resistance. Any hurdle in the flow of electric current is known as resistance. From this formula, the R is equals to the ratio of V and I, which is a constant. The resistances which follows Ohm's law are known as ohmic resistances, and the resistances which do not follow Ohm's law are known as non-ohmic resistances. The semiconductors and the diode valves are non-ohmic resistances. They do not follow Ohm's law. Next, we have discussed the graph. The graph for Ohm's law between the potential difference, that is V and I, is a linear graph. Is a straight line graph whose slope tells us the ratio of V and I, that is R. The slope of VI graph, the slope of potential difference to the current graph, tells us the resistance of the conductor. More the slope, more the resistance, and less the slope, less the resistance. Next we have discussed what is 1 ohm. The unit of resistance ohm came from volt by ampere. The unit of resistance is volt divided by ampere. What is 1 ohm? If 1 volt potential difference is applied across the ends of a conductor and 1 ampere current passes through it, that is known as 1 ohm resistance. Now we differentiate the conductors and insulators on the basis of resistance, on the basis of basically Ohm's law. Conductors are the substances which allow the electricity to pass through them. That means they have a very low resistance. So the materials which have very low resistance and allow the electricity to pass through them are known as conductors. Next, insulators. The materials which have a very high resistance, which have an infinite resistance, and due to that infinite resistance they do not allow the current to pass through them, are known as insulators. So the materials which do not allow the electric current to pass through them are known as insulators. Next बच्चों, resistors. The materials which have appropriate resistance. What do you mean by appropriate? Which have more than conductors and less than insulators. So they have appropriate resistance. They have an appreciable amount of resistance, neither too high nor too low. Those materials are known as resistors. Like the heating elements, they are included in the resistors. So this is the differentiation of the materials on the basis of Ohm's law. Now we will discuss the next topic, that is factors affecting resistance. In total there are 4 factors which affect the resistance. First is temperature, The second is nature of the material. The third is length of the conductor. And the fourth one is area of cross section of the conductor. First we'll discuss the temperature. In case of pure metals, the resistance directly related to temperature. What do you mean by directly related? If the temperature of pure metal increases, the resistance of the pure metal also increases along with them. In case of pure metals, if we increase the temperature, then the resistance of the conductor increases. So that is the reason why we apply the Ohm's law at constant temperature only. Because in case of pure metals, if we vary the temperature, the resistance of the material varies. At high temperature, the pure metal's resistance increases, and at low temperature, the resistance lowers down. So that's how the temperature is related to resistance. Second, nature of the material. We had discussed this topic earlier in this video. Insulators has infinite resistance, so they do not allow the electric current to pass through them. Conductors have very low resistance, so they allow the electric current to pass through them very easily. कंडक्टर्स का रेजिस्टेंस बहुत कम होता है, इसलिए करंट बड़ी आसानी से पास होता है। इंसुलेटर्स का रेजिस्टेंस बहुत ज्यादा होता है, इसलिए आसानी से करंट पास नहीं होता। The next is length of the conductor. Resistance of a conductor is directly proportional to its length. That is, resistance of a wire is directly proportional to the length of it. That means a long wire has a more resistance as compared to a short one, because resistance of a conductor is directly proportional to its length. Why is it so? More the length, more chances of collision between the electrons. Resistance क्यों है बच्चे किसी कंडक्टर का? Because the electrons of the charged particles collide with each other. जितनी लंबी लेंथ होगी उतना चांसेस है, उतनी ज्यादा प्रोबेबिलिटी है कि इलेक्ट्रॉन्स कीप ऑन कोलाइडिंग विद ईच अदर. सो विद इंक्रीज इन लेंथ द रेजिस्टेंस इंक्रीजेस. इसीलिए बच्चे जब लंबी वायर होती है तो वो जल्दी गर्म होती है. इट बिकम्स हॉटर सून एज कंपेयर टू द शॉर्टर वन, बिकॉज विद इंक्रीज इन रेजिस्टेंस, with increase in length the resistance increases. So resistance of a conductor is directly proportional to the length. That is, R is directly proportional to the length. Let us suppose this is the first equation. Next is area of cross section. Resistance of a conductor is inversely proportional to the area of cross section. That is, R is inversely proportional to area. What does it mean? If area is high, the resistance is less, and if area is less, the resistance is more. Directly proportional means if one quantity is increased, the other is increased in equal proportion. अगर लेंथ डबल हुई तो रेजिस्टेंस डबल, लेंथ ट्रिपल हुई तो रेजिस्टेंस ट्रिपल, लेंथ क्वाड्रपलेट हुई तो रेजिस्टेंस भी क्वाड्रपलेट, लेंथ हाफ हुई तो रेजिस्टेंस भी हाफ, लेंथ 1/5 हुई तो रेजिस्टेंस भी 1/5. इक्वल प्रोपोर्शन, बढ़ेगा तो बढ़ेगा, कम होगा तो कम होगा. बट इसमें ऑपोजिट होगा. इफ वन इज इंक्रीज्ड द अदर वन इज डिक्रीज्ड. इफ एरिया इज हाफ्ड द रेजिस्टेंस इज डबल्ड. If area is tripled, the resistance is 1/3. So this is what the inversely proportional is meant. Resistance is directly proportional to the length and inversely proportional to the area of cross section. We combine first and second. What is first equation? R is proportional to L and R is proportional to 1/A. This is second equation. Combine these two. We get R is proportional to L/A. R is taken as common, L/A. When we remove the sign of proportional, we get equals to with a constant, and that constant is rho into L/A. Where rho, it is referred as rho, RHO. Rho is the constant of proportionality and is known as resistivity of the material. Resistivity of the material is always constant. So R is proportional to L/A. When we remove the sign of proportional, we get equals to, and with equals to we get a constant, and that constant is rho, RHO, rho. Rho stands for resistivity of the material. So the formula of R in the form of resistivity, length and area is R is equals to rho into L/A. This is the relationship between resistant and resistivity. Now we will discuss the relationship between the resistance of the conductor and the radius of the wire, or radius of cross section of the conductor, or the diameter. First we'll discuss with the radius and then we'll go with the diameter. As we are aware that resistance is inversely proportional to the area. And the area of cross section is pi r square. Area of circular cross section is pi r square. Pi is constant. If pi is constant, that constant will goes into the proportional, and that will be equals to resistance of the conductor is inversely proportional to the square of radius of the cross section. So resistance of the conductor is inversely proportional to the radius of the cross section. Square proportion means if radius is doubled, the resistance is 1/4. The square of 2 is 4, and they are inversely proportional. So if one is increased, other one is decreased, but in the square proportion. If radius is 1/3, radius is decreased to 1/3, then resistance is increased 9 times, because 1/3 means 3 square is 9. So that's how the square proportional is all about. Next is diameter. This is proportional to radius square, and we all know radius is diameter's half. When we open the bracket, it will be equal to d square by 4, and when we solve it, simplify it, it will become d. 4 will be equals to 4 will goes on the top, becomes 4 by d square. From here we get radius is inversely proportional to d square. Right? 4 is constant, but and the constant will goes into the proportional side. So resistance is inversely proportional to the radius square as well as to the diameter square. If diameter is doubled, then resistance is 1/4. And if diameter is 1/3, then resistance will become 9 times, because it is related to the square proportional. So that is the relationship between the resistance of the conductor with area, with the radius and the diameter of the cross section. Now we will discuss more about the resistivity. How we get the resistivity? Resistance is proportional to length. Resistance is inversely proportional to area. We combine these and we get R is equals to rho into L by A. When we change it, we get rho is equals to R into A by L. So resistivity's formula is resistance multiply area divided by length of the conductor. The question is what is resistivity? Resistivity is a property of any substance or property of the substance due to which that substance pose a hurdle in the flow of charge, or you can say in the flow of electrons. That is resistance. It is the property due to which any substance, whether the best conductor or the poor conductor, has a resistance. If someone asks you why any substance has a resistance, because every substance has a fixed resistivity, and resistivity is the property due to which a substance possesses a resistance, due to which a substance has a fixed resistance, due to which it has a hurdle in the flow of electrons, and hurdle in the flow of electrons is known as resistance. So resistivity of a substance is a property due to which it stops, it creates a hurdle, it poses a hurdle in the flow of electrons. Next. Mathematically, what is resistivity? Let us suppose if area of the wire is 1 meter square and length of the wire is 1 meter. Resistivity is equals to R into A by L. Area is 1 meter square and length is 1 meter. 1 is cancelled by 1, so rho is equals to R. So mathematically, resistivity is equals to the resistance if area of cross section of the wire is 1 meter square and length is 1 meter. बच्चे mathematically resistivity क्या है? Mathematically resistivity is equals to the resistance of the wire if area of the cross section is 1 meter square and length of the wire is 1 meter. Simple है बच्चे वो. Resistivity का formula है R into A by L. If we make the area of cross section and length unity, that is area of cross section is 1 meter square and length of the wire is 1 meter, then resistivity will be equals to resistance. 1 से 1 cancel हो जाएगा और ये दोनों equal हो जाएंगे. So mathematically, resistivity of the conductor is equals to the resistance if area of cross section of that conductor is 1 meter square and length of the conductor is 1 meter. Next, a very important topic for your board exam: factors affecting resistivity. Resistivity of the material does not depend upon area and length. It does not depend on. Resistance depends on length and area of cross section of the wire, but resistivity does not have anything to do with the area of cross section and the length. It is independent of the length and area of cross section. It only depends on temperature of the material and nature of the material. Bachcho, resistance depends on all these 4 factors, but resistivity only depends on 2 factors, that is temperature and the nature of the material. With increasing temperature, resistivity of pure metal increases, and with the nature of material, resistivity will remain the same irrespective of the length and area of cross section. For example, I have this length of copper wire and this length of copper wire. If material is same, both the wires are of copper, then their resistivity is same, irrespective of the length. Suppose I have this much of thickness of copper wire and other one is this much. Both thickness are different. One is more thicker as compared to other. But both are the copper wires. The resistivity of those copper wires will remain same because the nature of these wires is same. Both of the material of the wire is same, that is copper. So these are the factors on which resistivity depends. Now we will discuss unit of resistivity. How we find the resistivity? R is proportional to L. R is inversely proportional to area. That will become L by A, and we get the resistivity. From here we get the formula of resistivity, that is R into A by L. For the unit of resistivity, we just fill the other units. The unit of resistance is ohm. The unit of area is meter square, and the unit of length is meter. We cut this meter from this square, so the unit of rho, that is unit of resistivity, is ohm meter. So the unit of resistivity is ohm meter. When the unit will be equals to 1 ohm meter, unity, if the area of cross section of the wire is 1 meter square and the length is 1 meter, then the resistivity is 1 ohm meter. So what is 1 ohm meter? If the resistance of a 1 meter long wire having a cross-sectional area 1 meter square is 1 ohm, then the resistivity of that wire is 1 ohm. If the resistance of 1 meter long wire, that means the length of the wire is 1 meter, the area of cross section is 1 meter square, and the wire has the resistance 1 ohm, then the resistivity of that wire is 1 ohm meter.